there, this is KP, the MAFG. Well, I turned the camera on and my camera popped up real high and I had to readjust it, so I hope I think everything's right now. Anyway, hope everybody's having a good day. We are talking about rectilinear motion, part 2. This is going to be a graph, and the next lesson, if you want to watch that one coming up, it's not going to be a graph, but it's going to be an equation, and you're going to have to interpret the equation, based on well, the initial equation, which would be the distance equation. In this particular case, this is a graph of the velocity. Okay, so we're going to have to really discuss this, and hopefully I can help you understand what this graph is all about. The graph is in orange, and so we want to talk about this graph of v at t right here. It says, given the graph of the velocity on the interval from 0 to 5, t is between 0 and 5, when is the speed of the particle increasing, decreasing, and on what intervals? There are two basic ideas that you need to remember when we're talking about whether a particle is increasing or decreasing. The first thing you need to look at is v at t. If v at t is greater than 0 and at the same time the acceleration with respect to time is also greater than 0 within that interval. Also, and of course, that would be increasing. I put a plus sign to represent increasing. It's also increasing if v at t is less than 0, negative, and at the same time a at t is also negative. This is also increasing. If the signs are different, if these signs are different, in other words, if v at t is greater than 0 but a at t is less than 0, the particle is decreasing. The speed of the particle is decreasing. If, on the other hand, the velocity is negative but the acceleration is positive, once again, either way, the speed of the particle is decreasing. And that's what we're looking at, the speed of the particle over a frame of time. Alright, so let's look at this. Now, when is the velocity increasing? Okay, when is the velocity increasing or greater than 0? It's greater than 0 as long as the graph, as long as v is above the x or the t axis. Okay, so v at t is greater than 0. Let's just go ahead and show that between 0 and 1, let's put this, v at t, let's see if we can find it. V at t is greater than 0. It's also greater than 0 here, so v at t is greater than 0 as long as it's above, even though the graph itself appears to be decreasing. You got to remember, you got to understand, as long as you're above this line here, we can't say the velocity is decreasing, okay? But we think it is, but it really is not. It's above the t axis. This is the t-axis right here. Okay? This is in terms of seconds. Or if you want minutes or hours or whatever you want. Okay? Alright. It's also increasing here. V at t is greater than 0. And I tell you what, let's do. Let's put the sign of it then. If it's greater than 0, it's positive. Positive, positive. Okay. In these cases here, between 2 and 3 and between 3 and 4, the velocity is decreasing. Okay? Well, actually, yes, it is. So, v at t is less than 0 here and here. V at t is less than 0 here. Okay? It is decreasing. The particle is decreasing here. Alright. Now, we haven't talked about the speed of the particle as of yet. Okay? We have not talked about that as of yet. What we have to look at, just remember, we have to look at both V and A at the same time. The velocity and the acceleration. Well, let's take a look at this. I'm not going to even graph the acceleration equation. I'm not. All I'm going to do is in between each of these intervals, we're going to look at the slope. Now, remember, recall, this should be easy for us to know because we should have learned this way back in Algebra 1. If the slope is positive, it's going to be leaning to the right. This is the slope we're talking about here. If the slope is negative, it's going to be leaning to the left. So we have a negative slope here if it's leaning to the left. So I'm going to show you how simple it is to determine whether the acceleration at time t is greater than 0 or less than 0. If it's greater than 0, it's going to lean to the right. If it is less than 0, the slope is going to lean, these little slope lines are going to lean to the left. Alright, so between 0 and 1, we already have established the fact that the velocity is greater than 0 by virtue of the fact that it is above the t-axis. We have already established that. But now let's look at the slope. Now I'm looking at the acceleration. Which way are these little blue lines leaning? I'm making tangent lines here now. Little bitty tangent lines. That's leaning to the right, isn't it? So A at t is also positive, isn't it? So what do we know about this particular, on this interval from 0 to 1, what do we know about the speed of the particle? It's increasing. Alright, it is increasing. So the speed is increasing on the interval. So this is what we're asking. Let's see. Well, we're looking for both increasing and decreasing. We're doing increasing first. Okay. Well, let's do both. We can go ahead and do both. It doesn't matter. We're saying in this interval from 0 to 1, S, all right, whatever, the particle is increasing. The speed, the speed is increasing between 0 and 1, simply because the velocity is greater than 0 and the acceleration is also greater than 0. Notice here that at 1, the acceleration, in other words, you let off the gas, right? You're letting off the gas right there, aren't you? All right, and I want you to notice too that the further away from the t-axis we get, the faster it's going. It's increasing in speed. The speed is increasing. Now we're going back toward the t-axis, but now I want you to notice v at t is still greater than, the velocity is still greater than 0, but look what's happening to the acceleration. Alright, so right here, look at this slope and this one. Which way are those tangent slope lines going? Which way are they slanting? They're slanting to the left. So that means that if this is a left slant, the slope is negative, so A at t is also negative. So A at t is less than 0. So here we have v at t greater than 0 and A at t less than 0, which means now between 1 and 2, alright, between t equals 1 and t equals 2, the speed of the particle is decreasing. I'll just say DEC. Alright. We'll just do it that way. DEC. Speed is decreasing between, let's put the interval down, 1 and 2. Okay. The reason why we put open parentheses here and here is because, well, we see that the velocity is 0 in the first place here. The acceleration is at 0. It's, you see, that slope is 0 at 1, isn't it? So we're just going to keep the open interval here. Now again, ask your teacher or professor which one is correct, but I do believe that authors are showing this. Okay, and that's what I'm going by too, what I have read and studied. Okay. Alright, here we go. Look at this. Now we're looking below the graph. We already know that v at t is less than 0. Alright. We know that that one is negative. Alright. A at t is negative on this one. Okay. Positive and a negative is a negative. Okay. Here we go. Let's look and see. Now, when do we know? How do we know the acceleration would be increasing or decreasing? Well, if the slope is positive, the acceleration is greater than 0. If the slope is negative, the acceleration is less than 0. Okay? Here we go. Look, this slope between 2 and 3 doesn't change from where it was from 1 to 2, does it? The slope of the tangent lines here are all, I should have it on the outside rather, okay, but the slope of the tangent lines are all leaning to the left. You see that? That's what we're finding here, is we're looking at the slope. When the slope is telling us what the acceleration is. Alright, what is the acceleration doing? Well, A at t is negative also, isn't it? And notice that this portion of the graph, of the V graph, is going away from the T line here. Alright? it's going away. The further away it goes, what do we know about this? It's supposed to be, that is speeding up. Okay? So yes, speed, let's put it up here. Speed is increasing on the interval from 2 to 3. Okay. Excuse me. About to sneeze. Alright. Alright, here we go. Look at this one here. After, between 3 and 4 though, we have the velocity, because it's below the t-axis, the velocity is decreasing. Okay? And notice here that the acceleration is leaning to the right. Right here, between 3 and 4, A at t is greater than 0. It's almost like you're putting your foot to the accelerator, to the accelerator, but nothing is happening here. Okay, so what's happening? Speed is decreasing. Okay, and notice here at, well, we could have looked at x equals, or t equals 2, the velocity changing direction. It's stopping. V at t, V at 2 is 0. Alright, which means now the particle is moving in a different direction. This particle is moving to the right. The particle now moving to the left here. Okay? Alright? But it's still moving. Alright? But here, look at the sign changes. Positive here. No, I'm sorry, negative here. Less than 0 is negative, last I checked. This one here is positive, right here. Acceleration. So the speed is decreasing. Here, the acceleration is equal to 0. A at 3 is equal to 0, isn't it? This is A at 1. A at 1 is equal to 0. Okay? Alright. Here we have the velocity here. V at 4 is equal to 0. V at 4, alright, is equal to 0. Right there. Alright. Alright, so let's go ahead and consider this partition here, and we'll be done. Alright, so we have the velocity is increasing. Alright. In between 4 and 5, it's increasing because it is above the t-axis. That's why the velocity is increasing. But now all we're looking at here is the slope of the tangent line. These slopes here. Alright. Leaning to the right, leaning to the right. Alright, so A at t is also greater than 0, isn't it? Which means that A at t is positive. So I have both the velocity and the acceleration positive, which means here the speed of the particle on the interval between 4 and 5 seconds, speed is increasing, isn't it? Alright. Let's box them in so that we will get these. We use red. Alright, let's box in our conclusions. From 0 to 1, speed is increasing simply because both velocity and acceleration are greater than 0. Right? Alright, speed is increasing here That should be decreasing rather. Speed is decreasing because the velocity is greater than 0 while the acceleration is less than 0. Right here, both the velocity and the acceleration are negative. Alright, so the speed is increasing between 2 and 3. Alright, I guess I should put an interval here between 3 and 4 here. Alright, and I should put an interval here between 4 and 5. Alright, like that. Alright, and then speed is decreasing. What happened? Well, the velocity is negative and the acceleration is positive, isn't it? Okay? Here, the velocity is positive and the acceleration is positive once again, just like it was from 0 to 1. Exactly the same idea. Alright, so the speed here is increasing here. And that's how you tell when. So if we just wanted, now you may be asked, when is the speed of the particle increasing? You would have to say it's increasing on the interval from 0 to 1, from 2 to 3, and from 4 to 5. So if you had to write this out, okay, real quickly, I should be done with this. Alright, so if we just want to say increasing, the speed is increasing, alright, on the interval, alright, intervals, okay, between where? We said 0 and 1, union with that with 2 and 3, union that with 4 and 5. Right? 2 and 3, yeah, 4 and 5. It may be that this is asking for just decreasing. Alright, decreasing. The particle, the speed of the particle is decreasing on the interval. Well, there's two intervals here. Let's see. Decreasing between 1 and 2. Union that with decreasing again between 3 and 4. Alright, sometimes you may just be asked one or the other. Maybe not both. I showed both because you needed to see both of them. Okay? Alright, so keep in mind what the rules are. If you've got this, you understand it then. Okay, and that will come a long ways to understanding our next lesson. Alright, so what we're going to do next time is we're going to have an equation, a position equation, S at t. We're going to find the velocity, we're going to find the acceleration, doing the derivatives of both, okay? And then from there we're going to compare the velocity equation with the acceleration equation, and then from there we're going to see at what intervals the speed of the particle is, say, increasing. Okay, I'll give you a little heads up on that for the next video if you want to see this. Alright, that's what we're doing next time. Given the position function S at t, where is, on this interval, from where t is between 0 and 6, including 0 and 6, on what intervals is the speed increasing, and all we're looking at is increasing next time. Okay, I will likely show decreasing too, but we are interested in answering though where is this increasing? I don't know when I'll give this video, probably tomorrow. I don't know, maybe today, but we'll see. Okay, I'm most likely going to wait till tomorrow on this one. Okay. Alright, that does it for today. This is KP the Math G, and I trust that you will have a very good and prosperous day. Thank you so much. And oh, by the way, before I clap, I usually clap to end the lesson. Make sure that you hit that subscribe button, please. The subscribe button, and make a comment. Now the comment, you can make a comment after I process this, which will probably be about 30 minutes later. Okay, you can make comments on this. Alright, anyway, KP the Math G signing off. Have a great day.